I'm going to compute the integral from 1 to 2 of 2x plus 1 dx, and I'm going to use the definition of integral and not antiderivatives. The first thing I always do is copy what the definition of integral is straight from my notes. The next step is to actually figure out what delta x and xi star are and substitute them into the formula. Delta x is the width of each little rectangle in the Riemann sum. I know that the formula for that is b minus a over n, and since b is 2 and a is 1, that means that delta x is 1 over n. I always use the right endpoint method to compute my Riemann sums, and so that means that xi star is going to be the right endpoint of each little subinterval of the interval 1 to 2. The formula for that which I've memorized is a plus I times delta x. A is 1 and delta x is 1 over n, and so I know what these two quantities are. I'm going to substitute them into my little integral here. Next, I'm going to look at what the formula for f is, and I'm going to use that. F of x is equal to 2x plus 1. And so when I plug 1 plus I over n into that formula, I get 2 times 1 plus I over n plus 1. Now I need to simplify that expression. I'm going to distribute the 2, add 1, and multiply both of those pieces by 1 over n, and what I get is 3 over n plus 2i over n squared. The next step now is to actually do the sum. Now 3 over n and 2i over n squared, I can actually sum those two pieces up separately. And 3 over n doesn't have any i's in it. And so when I add up this sum, it's like I'm saying 3 over n plus 3 over n plus 3 over n plus 3 over n, and I say that n times. And so that means that this sum is equal to n times 3 over n. Now the sum, as I goes from 1 to n of 2i over n squared, is a little more complicated. I'm going to factor out the 2 over n squared in front of the sigma, and now I have the sum as I goes from 1 to n of I. Now I know that n times 3 over n is 3, so I simplify that. And I also know that the sum as I goes from 1 to n of I is n times n plus 1 over 2. So I make that substitution as well. Finally, I'm going to compute the limit. And the second piece is a rational expression with a quadratic over a quadratic. After simplifying some, I can see that the limit of this expression is going to be 1. I can take the leading coefficient over the leading coefficient. And so this integral is equal to 3 plus 1, or 4. I'm going to go one step further here and try to visualize this integral with a graph. This is the graph of y equals 2x plus 1. And we were computing the integral from 1 to 2 of this function, which means the area under the graph from 1 to 2. So that's going to be a trapezoid shape, and I've also marked the lengths of the two sides of this trapezoid, 3 and 5. And if I were to compute the area of this trapezoid by hand, I would know that I would average 3 and 5, which is 4, and then I would multiply that by the width of the trapezoid, which is 1. And so I can see that this integral will be 1.